Hello my friends, welcome back to another video of Supply Chain Management complete course. In previous video, we were faced with a new concept, a new word, and it was physical internet. This concept is new in supply chain and shipping. So I decided to provide a separate video and talk a little more about this title. I'm sure we will hear more about physical internet in future, and it will change shipping methods formula, current shipping methods formula. Let's start it. Let's have an example. From now, we use PI instead of physical internet, okay? As a very simple explain, for physical internet, I think this is one of the best way. Imagine we have a truck which transfers goods from A point to B. A and B are two neighbor countries. In this situation, as I mentioned, truck in destination in B point should be stay for next order to come back to his house and A country. We know for a fact that 20% of all trucks in the United States are traveling empty at any one time. That's called deadheading. Having dropped off the load they were carrying, they now have to drive to the location where their next load awaits. Reducing the amounts of deadheading is one of the keys to reducing inefficiency in trucking. The physical internet suggests that the optimum means of transporting goods is by agreeing on a standardized set of boxes that could snap together into one 40-foot container. This would free the supply chain from fragmented shipments and proprietary dedicated networks. In theory, a single shipment can begin traveling by road, and if it encounters a problem, switch to another transportation mode, such as a rail or water, provided that mode is more efficient. Let me make it simple. Here we have an internet network. As you see, data shared between computers by the cable and other methods. There are some places where data comes together and named node. Cable and wire called link. It means the line that share data between nodes, right? Node help this transaction to become more fast and safe. But about physical internet. Terminal, airport, seaport, customs place, and each internal or external place in country which commodities store to transfer, it named node. Yes? And roads and seaway and railway called link. I mean the link between all kind of terminals. This is a new version of shipment. Don't need a truck travel between countries. Shipment will be shared between nodes, and all nodes have relationship between each other, and it will be more faster and safe. But to reach this method in real life, we need a different type of container which all types of vehicle can transfer. I mean new version of container. In this type of container, we have a 40-foot container that could divide it to a smaller part. About divided container to a smaller part, let's have an example. If you are shipping potato chips, you can fill the truck by volume and have only 11,000 pounds in the truck, leaving 29,000 pounds unused. Conversely, if you are shipping rolled steel, you will quickly reach maximum weight at about 200 cubic feet, leaving about 2000 cubic feet available. If you can get both the potato chip manufacturer and the steel manufacturer to work together, both would save money by getting a better rate and the container would have a higher utilization, increasing efficiency, improving quality of life for truck drivers. The physical internet also could address the vexing problem of high turnover and shortage for over-the-road OTR uh, truck drivers in the industry. Currently, an OTR truck driver, following the federal hours of service rules of uh, 11 hours cumulative driving in a day, would take about 4.5 days to haul a load from New York to Los Angeles. Then, depending on where the next load is picked up, the trip home would again be at least another 5 days, assuming you were able to get a full truckload going straight back to New York. More realistically, it will take 2 or 3 weeks that before that driver will get enough paying loads in the right direction to get back home. The stress of long spells away from home is one of the critical factors that leads drivers to quit long haul trucking. So imagine instead that the same driver hauls a full container comprised of differently sized, standardized individual models 5 hours to a hop, literally drops it off by unhooking the container from his truck, picks up another container, drops it off at a hop near home, and ends the night sleeping in his or her own bed. Meanwhile, that first container is picked up by another driver who hauls it 5 hours and drops it off where it is picked up by another driver and it goes to Los Angeles. In theory, the product never stopped moving and could make it cross country in 2 days. That heading is greatly reduced or eliminated. The driver's job satisfaction is immensely improved thanks to being home at night. Fewer trucks are on the road, which helps relieve traffic and greenhouse gas emissions. Sharing information, developing interconnectivity. These are admittedly simple examples, and yes, there are significant challenges to turning that uh, vision into a reality, including convincing the logistic industry to agree on a standardized protocols instead of proprietary system currently in place. Overcoming those challenges are what physical internet researchers are working on today. While the ultimate goal of a true physical internet might seem like attaining nirvana, there is no doubt that we will gain significant efficiencies as we share information and develop interconnectivity in the logistics system. They might not be 100% of what a fully realized physical internet would bring, but even a 10 or 20% increase in efficiency would mean billions of dollars in saving to the logistic industry and ultimately to all of us as a consumer. Anyway, it was interesting topic to me and I hope it could be amazing and useful for you. In future years we will hear more about this title. Okay, see you soon.